Hello everyone, I'm Ashlesh Tikami, a final year student of Computer Science and Engineering at East West University, Bangladesh. So today I'm going to explain my understandings from the code of hospital problem, which has been solved using optimization, which is the category of algorithm where the best option is being chosen from a set of options. Um, the implementation code has been taken from CS50AI course offered by Harvard. So I am going to tell you a little bit about the given problem. So we have two types of buildings, houses and hospitals. We have a bunch of houses and trying to find a way to place the hospitals on the map where the distance between the hospitals and any of the houses will be minimum. So we will be using a hill climbing algorithm to solve the problem. So let's see the code. First of all, here's a class is defined called space, which is going to represent the state space, and the state space has a height, width, and the number of hospitals. The number of hospitals will determine how many hospitals will be there in the map, for which we have to set the houses and the hospitals. Then there's a function called add house for adding new houses in the map. Then there's another function defined here called available spaces, which is going to represent the spaces where there is no hospital or houses. And if we want to add the hospitals randomly in this location, the candidate here is an object for considering all possible cells by taking the height and the weight of the state space, which will be represented as row and column. This part here is for removing houses and hospitals using the candidate object, which will return the candidate's object where all possible cells will be present. Now a function is defined here called climb, where the needed attributes are given and a count variable is initialized and set to 0. As we don't know uh, where we are going and the hospitals are going to go, so we are going to randomly place the hospitals in particular positions, which will be taken randomly. This loop is here is going to add the hospitals in random available spaces, which we have already determined by the available spaces functions. So this is the logging output, and the image prefix is going to generate some images. We will be seeing this when we will run the code. Then this loop here is for specifying the number of times the algorithm ran. The count value will be here the specifier. We have initialized it previously, as you have seen it. After that, this loop is for considering the hospitals that can potentially move. So as you can see, this part is for generating neighbors, insects, neighbors, and the sets of the neighbors for the hospitals. Here any neighbors can remove or add or replace the hospitals to another point. And here we are going to check if it is going to a better position or not. So if best neighbor cost is greater than the cost, then it is going to be better. So we are going to update our best neighbor, and it is recently found. Otherwise, we are going to append the neighbors to get the best neighbor. If none of the neighbors are better than the current state, in this case, the best neighbors is worse than the current state. Uh, so we shouldn't make any changes, and uh, return the hospital. Otherwise, we can update the hospitals by changing them randomly with one of the best neighbors if there are multiple or equivalent neighbors. Okay, so here every time we move the hospitals to its neighbors, it generates image as we were saying. Sorry, my Wi-Fi was stuck for a moment. In this part, we are gonna repeat the hill climbing algorithms, but at a number of fixed times for which a function random restart has been defined. In this loop, we are going to compare if the best cost is better or worse than the cost. If it's better, then we will update the best cost with the new best state. Otherwise, the current state will be found and the hospitals will be returned. The function here get cost is for calculating the sum of the difference is from the houses to the and the nearest hospital. First here, cost is initialized and set to 0, and the cost is being minimized by measuring the distance between houses and hospitals. And the minimized cost is returned here. The function get neighbors is for defining the neighbors, if the neighbors are containing a house or hospitals or not. If the neighbors are containing any house or hospitals, then the code won't make any change and continue. But if there's a better place, then the neighbor will append the place and will be returned. This part is here for generating images. Every time we will be moving and the hospital we will be moving to the hospitals to any particular state, there will be a movement and a new image will be generated, which will be updating the situation. And for input, we have for the input, it will be randomized. Every time we will run the code, the input will be taken randomly. And we have taken PNG file to represent the houses and the hospitals. Now we will run the hip timing algorithm in order and to try and figure out of where the hospitals should get placed. So I am going to run it from the command prompt. So I will be using its own directory for running the code. So as you can see there, see here, it has randomized and a pile of cost are here. The initial state was costed 91, and every time it found a better neighbor, the cost has been reduced and it finally reduced to 51. So we can see here's the PNG files are created. So if we see here, this was the first picture where the hospitals were randomly placed, and every time we found a better neighbor, we have moved our hospitals to a minimum distance of the houses. You can see this hospital is moving, and this hospital is moving to the nearest of the houses. And this time, this hospital was moved. By this, we found the ultimate result, which is the ultimate solution where the minimum cost was 51. Yes, this is the minimum cost of 51 result where the hospitals are placed at its minimum to and near of the houses. So that's all from my side. I have understand this much from this code. Thank you so much, everyone, for seeing the video.